Okay, today's lesson is over solving inequalities using addition and subtraction. So we're just going to kind of pick up where we left off yesterday. Okay, the problem on the board says, in a U.S. presidential election, a candidate must win at least 270 out of 538 total electoral votes to be declared the winner. Suppose the candidate has earned 238 electoral votes outside the southeastern United States. What is the least number of states in the southeastern U.S. that the candidate could win and still become president? What are these states? Justify your reasoning. And I'd like for you to pause the video and just kind of think about this and see what you can come up with on your own. Okay, so the way that I would think about this is if they have won, or if they have to win at least 270, that means they can win more than 270 or exactly 270. So X would be greater than or equal to the 270 votes that they should win. Then it says, suppose the candidate has earned 238 already. So we know that of the 270, they've already earned 238. So how many more would they have to get, that would be my X, in order for them to still get more than or exactly 270? And it said up here that we're using the southeastern states. So I have those kind of outlined for you. They're in the dark black. So what states would we need? Well, I'm going to figure out first how many electoral votes do they still need. So if I subtract 238 from each side, 270 minus 238 would be what? 32? So they need to get 32 or more electoral votes. So I'm going to go with the biggest first. Obviously Florida, because it says the least number of states. So Florida has 27. So if they did Florida and North Carolina has 15. So 27 and 15 is going to give me more than the 32 that I need. So that would give me the least number of states. That would just be 2. There's no state that has more than 32. So we'd have to have at least 2 states to be able to get to the 32 electoral votes that we still need. So we could do Florida and North Carolina. We could do Florida and Georgia. You could do Florida and even Tennessee. There's lots of different options on ways that you could get these just by having 2 states. Okay, and I have it set up here nice and pretty where you can actually read it instead of my chicken scratch. For some reason there's a lag again between the in the internet connection. I'm not getting very good connection. Okay, sorry about that. Hopefully this will work. I reconnected to the internet. So let's keep trying this. So anyway, I have this rewritten so hopefully you can read this a little bit better. But we knew that they already had 238 votes. We wanted to know, we were going to let X represent the number of electoral votes needed. And we know that that amount needs to be more than or exactly 270. And then we already solved it. And we found that they needed 32 votes. And then we found the states that could give us those. Okay, so let's try this problem. What are the solutions of x minus 15 is greater than negative 12? And graph those solutions. So think back how you would set this problem up if it was an equation. So x minus 15 equals negative 12. You guys would do the circles and squares at this point. And in Mr. Rose's class, and if you want to think about it that way, that works too. So, got my circles and squares. I just like to encourage you to think about why you're doing what you're doing. To move the negative 15 over to the other side of the equal sign, I'm going to add 15 to both sides because a negative 15 plus 15 gives me 0, so now I have x plus 0 over here, which is great because I wanted to get rid of that. Now negative 15 plus 12, same sign, add and keep, but if they're different signs, I subtract. 15 minus 12 is 3. Keep the sign of the larger number, and then it will be exact. So we have x is equal to 3. So if I go back up here to my inequality, that means that x is greater than 3. And we learned yesterday that if it's not equal to, there's no equal to in there, then we know we're going to want to put an open circle on the 3 because we're showing that it starts at 3, but it does not include the 3. And we want all the values of x that are greater than 3. So we're going to point to the right. Okay, so what is the solution of 6 is greater than or equal to x minus 3? So once again, I'm just going to pretend this is an equal sign and do it exactly like I would do an equation. If I want to get rid of the minus 3, I add 3 because negative 3 plus 3 is 0. If I add 3 on that side, I've got to add 3 on this side, so I have 9 is greater than or equal to x. I like for you to get in the habit of writing it with the variable first. So remember, if I flip-flop the variable and the number, I must also flip-flop the inequality. This says that 9 is greater than or equal to x, so we know that x must be less than or equal to 9. So I go to 9. I'm going to put a closed circle because I'm showing that it's not just starting at 9, but it also could be 9. We're including 9. So we want 9 or all of the numbers less than 9. And so that works. And we can pick one of these values out here and plug it into both and just make sure it's true. Is 9 greater than or equal to 1? Yep. Is 1 less than or equal to 9? Yep, that works. So we know we must have done it correctly. What are the solutions of t plus 6 equals negative 4? I would pause the video if I were you. Go ahead and give this a try on your own. We've done a couple together, so try this one by yourself. I'm going to put an open circle on negative 10 because I'm not including it. It's not equal to. And then I want all of the values of t that could be greater than negative 10. Once again, we could check it. Plug in a 1. Is 1 greater than negative 10? Sure is. We could plug it in up here. 1 plus 6 is 7. Is 7 greater than negative 4? Yes, it is. I skipped 2? I did. Okay. So it says the memory on your cell phone has a capacity of 120 gigabytes. You've used 85 gigabytes. You want to download some apps. What are the possible sizes of the apps you can have? So let's think about this for a second. We've got the current memory that we've used. You've got the size of the apps, and it says is at most a certain memory capacity. So let's go ahead and try this problem. Pause the video and see what you can come up with. How much have you used? Well, you've used the 85 gigabytes plus you want to download some apps. We don't know the size of the apps, so we could define our variable as x equals the sign of the apps, or not sign, size, sorry. Okay, so we've got the 85 plus the x, which is the size of our apps, is at most, so it can't be more than, but it could be less than, so is less than or equal to, is at most 120 gigabytes. And think about that. If it will only hold 120 gigabytes, we can't go over. So a lot of times people get confused thinking, well, what does it is at most mean? But think about it in terms of this problem. It says that we can only have 120. So we know it can't be more than 120, but it could be less than 120. Now we've got an inequality, and you can solve it. So what do you get if you subtract the 85 from both sides? You can get app sizes of up to 35 gigabytes. So X must be less than or equal to 35 gigabytes. Okay, go ahead and try this one. This is a nice problem because there are variables on both sides of the inequality symbol. So please pause the video and try this problem and then check your work. Okay, so first I subtracted 3w from both sides to get my w's together, and I got w plus 8 is less than or equal to 10. Then I subtracted 8 from both sides to get rid of the 8 and have w all by itself. So 8 take away 8 is 0, w plus 0 leaves me with just the w. 10 minus 8 is 2, and we want all the values of w that are less than or equal to 2. Okay, what are the solutions of 5y minus 3 is greater than 6y minus 9? So if I move, I don't like to have negatives, so I'm going to move this 5y over here with the 6y to get rid of it. So I'm going to have negative 3 is greater than y minus 9. Okay, so at this point I would add 9 to both sides. Negative 3 plus 9 is 6. So 6 is greater than y, or we can say y is less than 6. So I'm going to put an open circle on the 6, and I want all the values of y that are less than 6. Okay, here's some practice problems for you to try. Pause the video and work through these problems. There's 3. When you get done with those, there are 3 more for you to try. Okay, so hopefully you pause the video and you try the problems, and I'm going to post the answers up here. Let me drag them over here so you can actually read them. Okay, so why did it do that? I'm sorry. Looks like it must have posted them twice. Okay, let's try this one more time. There we go. So I moved my x terms over to the same side, so I had 3x minus 2x left me with x. I had that negative 6, I moved the positive 2 over there with it, so I subtracted 2 from both sides and got negative 8. Now, if you would have moved on this next one, let's say that you moved the x, or the 2x over here with the x, you would have gotten a negative. We're going to address that more tomorrow, what happens if you divide by a negative. But I just wanted to kind of avoid that today, and I avoided that today by subtracting x from both sides, and I ended up with x is greater than or equal to 3, and then back the third one, x is greater than or equal to 16. And here's you 3 more problems that you can try on your own, and then check your answers. I'm going to go ahead and walk through the process while I work it out instead of just posting the answers. So minus 6, I want to get that x by itself, so I'm going to add 6 to both sides. Negative 6 plus 6 is 0, so that got rid of it. 15 plus 6 is 21. So x is greater than 21. I'm not including 21, but I'm starting there. I want all the values bigger than 21. Okay, with this one, I want to subtract the 3 from both sides because I've got a positive 3. I want to get rid of it. So 3, take away 3 just leaves me with x. So I have x is less than or equal to 11 minus 3, which is 8. So I'm going to include the 8. I'm going to do a closed circle to show that it could be 8, or it could be anything smaller than 8. We know all the smaller values are to the left. And really, we should include on our number line one number above and below at least, so you can tell, but hopefully we all know that to the left is smaller and to the right is bigger. Okay, so I'm going to move this x over here with this x. I get rid of it from this side by subtracting it, so I end up with x plus 5 is greater than or equal to 9. At this point, I'm going to subtract 5 from both sides to get this x isolated all alone over here. So x plus 0 is just x. x is greater than or equal to 9 minus 5, which is 4. I'm going to 3, 4, 5. I'm going to put a closed circle on the 4 to show that I'm including 4. And then I want all the values of x that are bigger than or equal to 4. So I'm going to go to the right.